Hey guys, here we are looking at AS Level Maths past paper exam questions on differentiation involving normals and tangents. We have a 9 marker and an 8 marker. Let's do this. Okay then, number 1, a curve has equation y equals 6x root x and 32 over x, 4x greater than 0. Part A, find dy by dx. Alright, first step, write it in power form. So y is equal to 6x times root x is 6x times x to the half. So altogether that is x to the 3 halves. So we have 6x to the 3 halves, and then 32 over x is 32x to the minus 1. Okay, now we can differentiate. So dy by dx is going to be 6 times 3 halves, which is 6 times 3 divided by 2, so that's 9, x to the 1 half. And then for the 32x to the minus 1, we get minus 1 times 32, which is minus 32. X to the minus 2. Now, if you like, we could then write this as 9 root x minus 32 over x squared. Okay, then for part B, the point A lies on the curve and has x coordinate 4. Find the coordinates of the point where the tangent to the curve at A crosses the x-axis. Okay, so to be able to do that, we are going to need to know the equation of the tangent. To get the equation of the tangent, we need both coordinates of A, and we also need the gradient of the curve at A. So I'm going to start with finding the y coordinate. So when x is 4, y is going to be 6 times 4 times root 4. So that's 6 times 4 times 2, so that's 48. Add 32 over 4, so that's 8. So that gives us 56. So the point A is 456. Okay, next I'm going to find the gradient of the tangent. So when x is 4, dy by dx is going to be 9 times root 4, so that's 18, minus 32 over 4 squared, so that's 32 over 16, so that's 2. So we got 18 minus 2, which is 16. So that's the gradient of the tangent. Next, we can now find the equation of the tangent. So, using y equals mx add c, we now know that y is 16x add c. Now to find c, we sub in the coordinates of a. So x is 4, y is 56. That gives us 56 is equal to 16 times 4, which is 64, plus c. So take away 64, we get minus 8 equals c. So the tangent is y equals 16x minus 8. So we are nearly there. Now we want the coordinates where the tangent crosses the x-axis. So on the x-axis, y is equal to 0. So we substitute that in to the equation. So we get 0 equals 16x minus 8. And from that we get x is 1/2. So the coordinates are 1/2, 0. Okay then, second question, quite a monster. So the curve C1 has equation y equals 4x squared minus 6x add 4. The point P, 1/2, 2, lies on C1. The curve C2 has equation y equals 1/2 x add log 2x. The normal to C1 at the point P meets the curve C2 at point Q. Our job is to find the coordinates of Q. Right, so the first thing we are going to need is the equation of the normal to C1 at P. Alright, let's do that. So for the normal, first thing we're going to need is dy by dx, so that we can then find the gradient of the curve at P, and then we can get the gradient of the normal. So, dy by dx is going to be 8x minus 6. Now, when x is 1/2, dy by dx is going to be 4 minus 6, which is minus 2. So that's the gradient of the curve, or the tangent, at point P. So the gradient of the normal is the negative reciprocal of that. So it's going to be positive 1/2. Okay, now for the equation of the normal, we now know it's going to be y is half x add c. To find c, we plonk in the coordinates of p. So x is a half, y is 2. So that is going to give us 2 is equal to 1/4 add c. From that, we get c is equal to 7/4. So the equation of the normal is y is 1/2 x add 7/4. Now at intersection points, the two equations are going to be equal. So the equation of the normal is equal to the equation of C2. So we now want to say then that 1/2 x add log 2x is equal to 1/2 x add 7/4. Which is nice because the 1/2 x's cancel each other out. So take those off of both sides. We get log 2x is equal to 7/4. To undo a log, we exponentiate both sides. So 2x is equal to e to the 7/4. Which means x is 1/2 e to the 7/4. Now we need to find the y coordinate. Now the easiest way to do that is to now put our brand new x value into the equation of the normal. So we know the normal was 1/2 x add 7/4. So when x is 1/2 e to the 7/4, y is 1/2 times that, so that's 1/4 e to the 7/4 add 7/4. So the point Q is 1/2 e to the 7/4, 1/4 e to the 7/4 add 7/4. Good times. Okay then guys, that's it for this set. Next up, we are going to be doing real life differentiation problems. That's the next video in the playlist. Hope to see you there. Take it easy. Take care.